Hello, everybody. Welcome back to Geography 340 Climatology. Today's lecture topic is on climate classification systems. Once again, I am Zach, your instructor. Let's dive into it. So why do we classify things? Well, on a very basic level, it fills a very human need to derive order from chaos, let's say. So it lets us find relationships, compare different classes, or determine differences between things that we have to generalize in order to compare. And that's what classes do. They're descriptive bins that allow us to generalize between two places. So, for example, let's compare Eau Claire and Santa Barbara. We know the lat long coordinates for both Eau Claire and Santa Barbara. That's easy to find, but those don't really classify anything. That just tells us the location of something on the planet. We know the states or countries that both of those reside in. Eau Claire's in Wisconsin, Santa Barbara's in California. But those are political boundaries. Those don't necessarily allow us to compare anything. Without further insight or more descriptive terminology, all we really have are just locations or boundaries. But let's take, for example, climate classification. Eau Claire, we can say, is humid, continental, with warm summers, whereas Santa Barbara is Mediterranean with dry summers. Those are descriptive terms with definitions and values behind those descriptions that allow us to, much more effectively compare Eau Claire to Santa Barbara. So how do we think about these climates? Well, here's a generalized climate region for all of the world. We see some very useful things on here. We see the warm and the cold ocean currents by the bold arrows. We see dominant wind directions across major portions of the oceans. We see the intertropical convergence zone. But then we see the color coding, and the color coding says that we have tropical, dry, moist with mild winter, moist with severe winter, polar, and mountainous regions, climate regions. These types of bins and classifications allow us to compare an area in, say, northern Asia, northern Russia, to one in northern Canada, or compare that climate in the central landlocked portion of Australia to that of sub-Saharan Africa, or Chile and Peru, or the United States desert Southwest. These different classifications allow us to compare and say, well, how is one different to the other? There's a very famous one, the Köppen climate region or Köppen climate classification system. And we're going to dive into what each one of these means. All save the very last one in the bottom right corner there, Highland. We're going to kind of ignore that one for now. But this is the prominent classification system used by most scientists. So who was Vladimir Köppen? Well, he lived from 1846 to 1940. He was a Russian-German scientist born in St. Petersburg, moved to Germany. And he was a climatologist, a meteorologist, a botanist, and if you really think about what he did, a geographer as well. He initially published this classification system in 1923 with a German colleague, Rudolf Geiger. Geiger then continued to revise this until the 1960s, and then it was updated again in a much more rigorous manner by a team of Australian scientists in 2007 who used 70 years of temperature and precipitation data to refine and improve the Köppen-Geiger system. So we're going to pause here, and if you haven't already, I'd like you to go to Canvas and go under the handouts link, which should be on the very top of the Canvas page, and you will download the two handouts you see there, the Köppen climate classification flowchart and the verbal explanation of the Köppen symbols. So we're pausing, and we're going. I'm hoping that you paused and downloaded that if you hadn't already. So the Köppen climate classification system, as I said, is the most widely used for classifying the world's climates. Köppen divided Earth and Earth's surface into climatic regions that generally coincided with world patterns of vegetation and soil. Now remember, as we said, he was a botanist. He was interested in the dispersion of plants and how that dispersion related to the climatic, meteorological, botanical variations across the planet. So the Köppen system recognizes five major climate types based on annual and monthly averages of temperature and precipitation. So the first four designators that we're going to talk about focus primarily on temperature, and the last one we'll talk about focuses on precipitation. So we see here the primary designator is the A, B, C, D, or E systems. So A, C, D, and E all relate to temperature, whereas B relates to precipitation. So here we see the first letter symbol. So A is for tropical climates with monthly temperatures greater than or equal to 18 degrees Celsius. C is for temperate or mesothermal climates with average temperature of the coldest month at least -3 degrees Celsius and the warmest month at least 10 degrees Celsius. D is for continental or microthermal climates with the coldest month less than -3 degrees Celsius and the warmest month at least 10 degrees Celsius. E is for polar climates where monthly temperatures are all less than 10 degrees Celsius. And B is for dry climates where potential evapotranspiration exceeds precipitation. And to see whether you have a B climate or not, we have to look at the handouts and we have to look at figure 1. So here's figure 1 and figure 2. We're not really going to dive into these and plot anything on these just yet. But if we look at figure 1, we see the titles for each of the graphs are even distribution, summer concentration, or winter concentration. And what that means and relates to is the distribution of precipitation across the year. So what you want to do if you need to find out whether you have a BW, BS, or AC, D, or E climate is you take you divide the year into two. So you take April to September, and then you take October to March. And you calculate the amount of precipitation cumulative within each of those two bins. And if your quantity exceeds 70% of the annual total in the summer or the winter, it falls into the corresponding concentration. So if I had 75% of my rainfall fell during the summer or April through September bin, that means I would have a summer concentration. Likewise, if it was a winter concentration, but if it's not, if it's below 70%, we have an even distribution across the year. And then figure 2 is to help us figure out whether we have an AM, AF, or AW/AS climate. So AM is for monsoonal, AF is for tropical rainforests, and AWAS is for savannas. So we'll dive into those specific designations here in just a little bit. So the second letter symbol, so AF, CS, or DW, is assigned by monthly to seasonal precipitation. So AF, or F, the F designator, suggests that there's precipitation all year with no dry season. So if you have an A climate, you'll want to see figure 2, but for C and D climates, if every month receives at least 30 millimeters of precipitation, you have an F climate. Monsoon, or M, is only in A climates with very short dry seasons. And if you have one of these, or if you think you do, see figure 2. For S, that means that summers are particularly dry. For A climates, see figure 2. Otherwise, if the precipitation of the driest summer month is less than or equal to 1/3 of the precipitation of the wettest winter month, you have an S. On the other hand, you have a W for dry winter if in the case of figure A, or in the case of an A climate, you see figure 2. Or in other cases, the precipitation of the driest winter month is less than or equal to 1/10 of the precipitation of the wettest summer month. T and F are only for E climates. That means tundra, where the warmest month is at least 0 degrees Celsius, or frost and ice for F, where all months are less than 0 degrees Celsius. And S and W are only in B climates, and S means steppe, and W means desert. So see figure 1 if you think you have either of those. And they correspond to precipitation and temperature differences. The third place letter is assigned according to certain monthly or seasonal temperatures. And these are A, B, C, D, H, and K, where H and K are only in B climates, and D is only in D climates. A is for hot summer, where the warmest month is greater than or equal to 22 degrees Celsius. B means it's a warm and long summer. At least 4 months have temperatures of 10 degrees Celsius or above, but under 22 degrees Celsius. C means short summers with 1 to 3 months have precipitation, where 1 to 3 months have temperatures of 10 degrees Celsius or above, but under 22 degrees Celsius. D means severe winters. This is only in D climates, and the coldest month has to be less than negative 38 degrees Celsius. H is for hot, pretty obvious or easy. Annual temperatures are greater than 18 degrees Celsius. And K is for cool, and that's also in B climates only, and the annual temperature is less than 18 degrees Celsius. So here is the distribution of A climates across the world, right along the equator. Pretty obvious, right? It's tropical. Most of your tropical rainforests and savannas and monsoonal areas all fall along around the equator. And we have 3 different subtypes here. We have tropical rainforest, or AF, where precipitation in the driest month is at least 6 centimeters or greater. Tropical monsoon, so precipitation in the driest month is less than 6 centimeters, but greater than 4% of the total annual precipitation. And then we have tropical wet and dry savanna, or AW. Here, precipitation in the driest month is less than 10 centimeters and less than 4% of the total annual precipitation. So this region hosts substantial biodiversity, if we think of what Köppen was interested in, with enormous trees or the potential for organisms of exceedingly large biomass, very thick, organic, rich soils. Here we see the distribution of B climates, kind of on those mid-latitude or low mid-latitudes, so around 20 or so degrees north and south. We see prominent areas of the desert Southwest, the African deserts, the Australian deserts, the Atacama in South America, and then most of the Middle East. And here we have the 2 subtypes, where we have arid deserts with annual precipitation is less than 50% of the precipitation threshold, and semi-arid steppes, or BS, where annual precipitation is more than 50% of the precipitation threshold. Now that corresponds back to our figure 1. And in this region, the plants are very drought and heat tolerant, or tend to be very drought and heat tolerant. And the soils can be oftentimes dry or hard packed. You can have sandy soils, dune systems. You can have very clayey soils as well. We move into temperate climates, or C. Here we see kind of your warmer, more temperate regions, as you'd expect. The United States Southeast, the kind of, we'll say, temperate rainforests of the northern west coast into British Columbia, much of Western Europe, getting down to areas around Sydney and into Vietnam, China area. Here we have three subtypes. We have Mediterranean dry summers, CS, where precipitation is in the driest month of summer is less than 1/3 the amount of the wettest winter month. Humid subtropical dry winters, CW, where precipitation in the driest month of winter is less than 1/10 of the amount of the wettest summer month. And then humid subtropical, or CF, that doesn't satisfy the S or W designators. So the CS includes CSA and CSB subtypes. CW includes CWA, B, and C subtypes. CF are described as CFA, humid subtropical climates that are moist all year, and B and C climates, which are marine west coast climates with mild to cool summers. Then we move into continental climates. This one should hit relatively close to home. The continental dry summer, or DS, where precipitation in the driest month of summer is less than 1/3. We know these designators here, but an A designator for the third letter signifies humid continental climates with hot summers. B designators signify humid continental climates with mild summers. C designators signify subarctic climates with cool summers, and a D designator signifies subarctic climates with cold winters. And then our polar climates. While it might feel like we're in a polar climate from time to time, these are much higher in latitude, typically 70 to 80 degrees north and south latitudes. We see the Arctic and the Antarctic. But we also see one little region in kind of Central Asia, South Central Asia. And if you're wondering what that is, it's the Himalayas. I think where the Indian plate is kind of crashing into the Asian plate there, and we have the Himalayas and K2 and Mount Everest and all these massive mountains. That is altering and actually is designated as a polar climate based off of its elevation. And here we have ET for tundra, where the average temperature in the warmest month is between 10 and 0 degrees Celsius, and EF for ice caps, where the average temperature of the warmest month is 0 degrees Celsius or below. Frigid. So we're going to take just a brief moment to pause here. We've got a group of examples coming up. I will have the answers for them at the bottom. We'll flip to them right now. So I'll have the answers for these listed in the description below, but take a moment to pause the video here and just try and work these out and see if you can kind of figure out what the climate classification for Libreville, Gabon, Cape Town, South Africa, and Karachi, Pakistan are based off of the temperature, the average temperature, and the precipitation. So like I said, I'll have the answers for these listed below, but try and figure it out. Surprise! Random homework assignment. That's how we'll end this one here, this video. So this one, you're going to go to this website, which will also be in the description below. You will select a state and a weather station of your choice. You're going to record that station's name, elevation, and lat-long coordinates. You're going to download its climate normals for monthly temperature and precipitation and annual temperature and precipitation. You're going to convert the data from English units, if it's in English, or imperial units, to metric units, because we are scientists and we will work in metric. So that'll be degrees Celsius for temperature and millimeters for precipitation. You're going to enter that data neatly and clearly formatted into a table on a page in Microsoft Word or some other word processing app. Above the data table, you're going to type the station's name, the elevation, the latitude, longitude coordinates so that I can see them. Below the table, you're going to type Köppen Climate without the quotes, but with the little colon there, followed by its 2 or 3 letter Köppen Climate Classification using your flow chart. You're going to figure this out. Please do not do one of the ones we've done or talked about before. Pick one that's fun or pick one that's close to home and see what you come up with. And then, this is paramount, save your document as a PDF. Canvas doesn't always like Word documents that aren't Word, or maybe they're Google Docs, or maybe they're Pages, or maybe they're rich text format. Sometimes Canvas doesn't like that, but what it does typically like, and I will have it locked for the submission, it has to be a PDF. So just save as a PDF or print as a PDF, and you'll be good to go. And then upload this PDF to Canvas under your random assignment 1. So just to kind of recap, we talked about what Köppen Climate Classification is, why we classify things, and then we kind of stepped through each of the different distinguishers for climate type. If you have any questions, feel free to reach out to me. The next video is going to basically be all about looking at those designators and understanding where they come into play and how places that we see as vastly different might actually be the same climate, but how vastly different those can look. So I will leave you with that. Feel free to reach out to me with any questions, and we will see you in the next video. Thanks.